Hi everyone and welcome to AWS Direct Connect support for AWS Transit Gateway webinar. This is myself, Mohammed Hassan, Senior Product Manager in EC2 Networking and the Product Manager for Transit Gateway. And we have Sanjay Pahal, Principal Product Manager in Direct Connect AWS. Let's go over the agenda for today. Today we'll cover AWS Transit Gateway, an overview of AWS Transit Gateway, and a recap of previous webinars that we have. And we'll also get an overview of AWS Direct Connect, and then we'll talk about how both come together, as in connecting AWS Direct Connect with your Transit Gateway and how it works. Then we'll cover use cases and limits, and then we'll go on a demo just to show you like step by step how we do it. So AWS Transit Gateway is a product that we launched in reInvent last year. And basically, it's a hub and spoke, if you want to think of it. It'll give you routing in AWS. With Transit Gateway, it's a service that allows you to centralize your VPC connectivity. So you can connect a large number of VPCs, up to 5,000 VPCs, and VPN into your Transit Gateway. And later I'll show you how you do direct connect into that. It gives you increased throughput with VPN because you have the ability of doing equal cost multipassing between your VPN. So you can create, let's say, like 10 tunnels, and you just spray traffic across them. ECMP will do equal cost multipassing between these tunnels, which gives you effectively roughly like 15 gig of bandwidth. And you can go up to 50 gig of bandwidth with VPN in the Transit Gateway. Also, you have the flexibility of routing domains, which is similar to virtual routing and forwarding in traditional routers. Routing domains allow you to segment your network. So you can create a routing domain for your dev network, a routing domain for your prod, routing domain for your test, and then you could have a routing domain for your shared services, which can be shared across all the other routing domains. Also, you can use routing domains with your VPN and Direct Connect so that you can share this across all different services you have, like whether it's prod, test, or dev. It's built on a horizontally scalable platform, and I'll talk about that in a bit. It's called Hyperplane. I'll talk about it in the next slide. Also, it's simplified management because you have everything in one place. You can define your routing policies, how your VPC attach, and the attach and all that, and your VPN and Direct Connect all in one place, whether you're using AWS Console, API, or Cloud Formation. Also worth mentioning that AWS Transit Gateway is cross-account. So you create a Transit Gateway, and then you can use Resource Access Manager to share it with your accounts. And then once you share it with an account, it will be visible to them. It can be done across organization or within the same organization. So let's talk about AWS Hyperplane, which is a platform supporting Transit Gateway, or the underlying infra for Transit Gateway. Hyperplane is a highly horizontally scalable platform. It's a cellular architecture, and it can process like terabytes of multi-tenant data across it. Also, it's a platform that we've been using for our network load balancers, NAT gateways, private link, and EFS. And now we are using it for Transit Gateway. It's a layer 3 version of that. So how it works is simply when you create a Transit Gateway, or when you attach Transit Gateway to your VPC, you create multiple attachments. You select which availability zones in your VPC where you attach your Transit Gateway. Let's say in this example, you have selected 3 availability zones. So we place 3 ENIs in your VPC. And then traffic from these ENIs are shorted across different cells, as you can see here in the diagram. Now, let's say you attach a second VPC. Again, your traffic will be sharded across different shards, which are different from the ones below. Like here you have a purple VPC, orange VPC, each one are landing in different place. So it's highly available and highly scalable. As you push more traffic, we add more shards. And also when a shard fail or when one of these cells fail, to be replaced immediately. So it's highly available within an availability zone. And then within a region, you have the ability to decide how many availability zones you want to have attachment in. In that case, we're using 3. So it's highly available within a region. So it's highly scalable and highly available platform in that sense. Now let's look at from architecture perspective, like before Transit Gateway, if you had that number of VPCs, how would you connect them? you would have used traditional peering, where you peer point to point between these VPCs and create a mesh if you want to connect all your VPCs together. Also, for each VPC, you would create a VGW and then a VPN tunnel, and then you could direct connect with and connect it to that VPC. Adding VGW and VPN and a VIF could take some time because it requires you to touch your on-premises router. So you have to go to your customer gateway, do a configuration change on that, which in certain cases could take hours, days, or even months in some cases. So adding a new VPC would require a lot of extra work to do to just adding a new VPC. And we've seen customers who want to move to micro account architecture or like have an account vending architecture where every new user gives them an account, or every new teams they get an account, or every new service get an account, and you want to go to multiple accounts, and each account gets their own VPC. So if you want to scale to that architecture, if you want to have multi-account, multiple VPCs, it's going to take you a lot of time to like build in such a mesh where you have to connect that VPC to all VPCs, all services, where you have to add VPN and add Direct Connect. Not only that, but when you're trying to build a mesh, it grows as your number of VPCs grows. Like it's n into n minus 1 over 2 peering connection between your VPCs if you want to build a full mesh. So if you have like 100 VPCs, that's like 4,950 peerings. So you can imagine how hard is it to manage all this number of peerings or point-to-point peerings. What Transit Gateway offer is a hub and spoke model. So you create the Transit Gateway and then you attach your VPN, you attach your Direct Connect. You already have done your configuration on-prem. You have configured your on-premises routers with Direct Connect and with your VPN. Now, every new VPC, all what they need to do, whether it's in the same account or cross-account, all what they need to do is to just attach to the Transit Gateway. And once they attach to the Transit Gateway, they point the routing to the Transit Gateway. Let's say you use a summary route like 10/8 or 172/8, or you simply use a 0/0 pointer to Transit Gateway if you're not using an IGW. And then when you point to the Transit Gateway, all your traffic will be sent whether to other VPCs or on-prem. And in Transit Gateway, you can define your routing policies using the routing domains. We do have other like webinars on Transit Gateways that you can refer to that talks about details of how you use routing domains, how attachment works, propagation, and all that. We also have a couple of reInvent session, Net 331 and Net 402. I recommend going into that in details if you want to dive deep into the details of using Transit Gateway and routing domains and how you create a network policy with Transit Gateway. With that, I will pass it to Sanjay to talk about AWS Direct Connect.
Thank you, Mohammed. AWS Direct Connect provides you dedicated private pipes into AWS. You can get connectivity directly from AWS, or you can work with hundreds of our partners to consume AWS Direct Connect service. When you use AWS Direct Connect service, you get several advantages. You get cheaper data out rates than you would get when you do your data transfer out over the internet. Data transfer in is still free. We do not charge for that. You get a very consistent network performance compared to what you would get when you use internet. You have selection of 91 locations in 65 cities in 28 countries to choose from. So you can select the best location for your needs. Once you have established a direct connect connection or multiple direct connect connections, you can share them across multiple AWS accounts. And you can use these connections to talk to your workloads across all AWS regions except regions in China. We support monitoring capabilities through CloudWatch for your dedicated connections. So with AWS Direct Connect, you can connect your on-prem networks with AWS. Now, when you connect these networks, it's important to talk about redundancy. To maximize availability, we highly recommend that you have multiple connections at 2 or more locations. Those connections must be configured to access your workloads in a redundant manner. That way, you are assured of your connectivity between your on-prem network and your AWS workloads. Now, let's talk about how you can utilize your AWS Direct Connect with AWS Transit Gateway. To access Transit Gateway, you can use your existing 1, 2, 5, or 10 Gbps connections. It can be dedicated or hosted connections. Hosted connections are provisioned by our partners. Dedicated connections are something that you actually get from AWS, but work with partners to provide and provision. To consolidate all your connectivity to thousands of VPCs through the Transit Gateway, we have introduced a new type of virtual interface called Transit Virtual Interface. You use Transit Virtual Interface and attach it to the Direct Connect Gateway to access your transit gateways in the supported AWS regions. Today, we support 4 regions: US East 1, US East 2, US West 1, and US West 2. So your transit gateways in those regions can be interfaced to your on-prem network using your Direct Connect connections.
So now let me walk you through how it works. We'll go on first how you set up your transit gateway, and then Sanjay will walk us how you set up AWS Direct Connect, and then how you set it both together. So in Transit Gateway, first you create a Transit Gateway, create VPCs. In that example, we have 4 VPCs, but you can do up to 5,000, as we mentioned earlier. You attach your VPCs to the Transit Gateway, and then you update the VPC route table. So first step is create your VPCs if you don't already have them. If you have VPCs, you can just use them with Transit Gateway. Next step is create your Transit Gateway. And in that, you specify a Transit Gateway name, you specify an ASN, and when using Transit Gateway with Direct Connect Gateway, you have to make sure you use different ASN for each. So your Transit Gateway ASN must be different from your Direct Connect Gateway ASN. And then you have options that are selected by default, like DNS support, which allow you to do DNS resolution over Transit Gateway. We also have ECMP support. This is equal cost multipath for VPN. When it's enabled, we will distribute traffic over VPN tunnels in Transit Gateway. Also, when you create a Transit Gateway, you get a default route table. That's where all the attachments and all the route propagations goes into. If you want to override that and you create your route table, you can do that by unchecking these options there. Now you have created your Transit Gateway, you can go to the console and see it. It takes a couple of minutes, maybe up to 5 minutes to get created. And once you see it, you'll see the Transit Gateway in available state, and then you will see your default route table over there. You can click on that default route table to see what is in there. Next step is to create a VPC attachment. So in here, you go select the VPC you want to attach. You select the Transit Gateway, and then you create the attachment. As I mentioned earlier, Transit Gateway is a regional object, so with zonal attachment. So in here, you have to select the availability zones where you want your Transit Gateway to be placed in a VPC. We recommend you select 2 or more, depending on your workloads in that VPC. You repeat that step for all your VPCs. You can use like a script for automating that if you are having high number of VPCs or AWS CLI or CloudFormation. Next step is to go look at the Transit Gateway route table. So in the route table here, you will see we have dynamically propagated the CIDRs of the VPC. You can disable that when creating a Transit Gateway if you don't like dynamic propagation and you want to use static routes. And in that case, we dynamically propagated the CIDRs of your VPCs. If you resize the VPC, the CIDRs will also be propagated here. Now, your last step in attaching VPCs in a Transit Gateway is to set up a route towards a Transit Gateway. So you go into your VPC, either your main route table or your subnets route table, and you specify a route toward your Transit Gateway. In that case, you can use a summary route like a 10/8 or 172/8, or you can use a 0/0 if you don't have an internet gateway in your VPC. And now Sanjay will walk us through how to set up AWS Direct Connect.
Thank you, Mohammed. So now let's talk about how you can interface to this transit gateway using AWS Direct Connect. Prerequisite is you need to have either 1, 2, 5, or 10 Gbps dedicated or hosted AWS Direct Connect connection or multiple connections. The steps are, first you create a Direct Connect gateway. We recommend you create a new Direct Connect gateway. Create your transit WIFs on the connections that you have. Attach transit WIFs to the newly created Direct Connect gateway. So basically, now you are taking your connections and connecting your on-prem network to your Direct Connect gateway via transit WIF. Once that step is done, you're ready to associate up to 3 AWS transit gateways to your Direct Connect gateway. After that connection or association is complete, establish the BGP protocol session with the Direct Connect gateway. Let's go through those steps using the console. So over here, first I'm creating a Direct Connect gateway. As we mentioned before, you must make sure that the ASN you select for Direct Connect gateway is different than the ASN you have for your transit gateways. So over here, I am creating a Direct Connect gateway with 65,000 as the ASN. Now I'm ready to create a virtual interface. In this case, we are creating a transit virtual interface. There are several things that you need to select here. You give a name, you select the connection. As I mentioned, you need to have either 1, 2, 5, or 10 Gbps dedicated or hosted connections. This virtual interface can be created in your own AWS account or in another AWS account. In this case, I'm creating it in my own AWS account. I'm giving it a name, virtual LAN tag number, and then the ASN that you will use from your end. And then this step is complete. Now let's talk about how we associate Direct Connect gateway to the transit gateway. As we mentioned earlier, we can support interface to your transit gateways in 4 AWS regions: US East 1, US East 2, US West 1, and US West 2. In here, I have a transit gateway in US East 1. I have selected that. And I have also put a prefix into allowed prefix list. You can add up to 20 prefixes. These are the prefixes that will be announced towards your on-prem network over the transit WIF.
So now after you have created your transit gateway, you created your AWS Direct Connect gateway, and you have stitched them together, talk about use cases. So here's the most common use case is connecting VPCs at scale to on-prem. In here you have like a large number of VPCs, whether you're like segmenting your VPCs like 1 per user or your 1 per department, or how you're segmenting your accounts in general. And what we see is commonly like you'd have different accounts, and each account will have a bunch of VPCs. And these VPCs are connected to the transit gateway. And this transit gateway is a multi-account, so you can connect VPCs from different accounts to your transit gateway. And then here you want to bring your direct connectivity to these VPCs. So you connect your Direct Connect gateway to the transit gateway. Here we're using the default route table, so everything is getting propagated in the default route table. You can see up here there's a route that got propagated from on-prem to your transit gateway. There's a 172 route. And then each VPC route is propagated into the route table. For propagation from your transit gateway to the on-premises router, you need to specify which routes to get propagated. And then that's preferably going to be a summary route. So since all your VPCs are in 10 dot, you can do a 10/8 summary route, and that will get sent down. So just be aware of the BGP flow. BGP from on-prem comes dynamically from Direct Connect gateway into transit gateway into the route table. BGP from your transit gateway, you have to specify what gets pushed down through the allowed prefixes. Another use case is we talked about a single region with multiple accounts and multiple VPCs. Here we talk about multiple regions with multiple VPCs and again multiple accounts. So in that case, you could have two transit gateway in different regions, and then you have a direct connect gateway, which is a global attached to this two transit gateway. So you're bringing your AWS Direct Connect, let's say from Virginia here, Ashburn, into your US region transit gateway, and then in your EU region transit gateway. And you can do up to 3 transit gateways per Direct Connect gateway. So that way you can build your global network using Direct Connect gateway and transit gateway. And in the future, as we mentioned in the past webinar, that we're planning to support cross-region ping between transit gateway, so you could have transit gateway talk directly to each other. Third use case, and this is just giving an example, but you have all the constructs like transit gateway, VPCs, routing, net gateway, and private link, and you can build different use cases depending on really your needs. So in this example, we have use case where you're trying to send traffic from on-prem to the internet and passing through cloud service. That will be like IPS, IDS, or firewall, or any other middle box service you're running. And in here, you would attach your Direct Connect gateway to the transit gateway, and then transit gateway to outbound VPC, and then the outbound VPC will send traffic out to the internet. We decided to use VPN between the outbound VPC and the transit gateway so that you can benefit from BGP and the scalable ECMP. In that case, you just set up the routes from your transit gateway to point to the outbound services, and then the outbound services will send it out to the IGW after it passes through the service. And when traffic coming back from the internet, it will go to the box, to the middle box, and then to the VPC route table, and then transit gateway, and then goes down through that Connect gateway to on-prem. In that example, also use routing domain just to illustrate how you separate your outbound service from your Direct Connect gateway route table. Now we'll talk about the limits. So Sanjay, you want to go over that?
Yes, so Direct Connect service has several limits that you need to be aware of. For each dedicated connection, we support up to 50 public or private virtual interfaces. You can have only one transit virtual interface per dedicated connection. If you have a hosted connection through our partner, you can have either one transit WIF or a public WIF or a private WIF. For each Direct Connect gateway that is attached to the transit WIF, you can have up to 3 transit gateways association. Direct Connect gateway can support up to 30 virtual interfaces, so you can attach either a transit virtual interface to a Direct Connect gateway or a private virtual interfaces to a Direct Connect gateway. You can have up to 30. You can advertise up to 100 prefixes from on-premise towards AWS. If you are associating a transit gateway to a Direct Connect gateway, you can advertise up to 20 prefixes from a transit gateway towards on-prem. You can associate multiple Direct Connect gateways to a transit gateway. You can have up to 20. So when you plan your network, please take care of these limits.
Okay, now we'll go through kind of the most common frequently asked questions, and we also have additional questions from you once we open the floor for questions. So what is the bandwidth limit for Direct Connect gateway attachment? So generally this is bound by your Direct Connect gateway itself. So if you have like 1, 2, 5 per gig, that would be the first limitation in bandwidth. And then you can do up to, like if you're creating a lag, up to 50 gig, which what we do for VPN and VPC. Second question is, can I use my Direct Connect location to reach transit gateway in any region? So Sanjay, you want to pick that up?
Yeah, I think that's a great question. So yes, if you have a dedicated or a hosted connection at any Direct Connect location, You can create a transit WIF on those dedicated or hosted connections and attach it to a Direct Connect gateway and access any transit gateway in supported regions.
So we get a question which is common, like it's now available in all 4 US regions. When is it going to be available in other regions?
Yeah, we are actively working on supporting additional regions. So please look at our What's New pages. We will announce additional region support over there.
And how many transit WIF can I have per connection?
You can have one transit WIF per dedicated or hosted connection with capacity greater than or equal to 1 Gbps.
And does it make a difference if I use a lag or not?
No, by default, lag is considered a single connection, so you'll get one transit WIF. If you have a specific use case, you can work with your account team and work with us.
Got it. And how many Direct Connect gateway can I connect to Transit Gateway?
So you can request up to 20 Direct Connect gateway attachments to a transit gateway attachment.
Got it. So just to recap here, like you get one transit WIF per connection, and then you can have up to 30 transit WIFs per Direct Connect gateway, and then up to 20 Direct Connect gateway per transit gateway. Is that correct?
That is correct. And we highly recommend that you have multiple transit WIFs terminating and attaching to a Direct Connect gateway for increasing your resiliency and for maximizing your availability.
Perfect. So you can also have more details on both products like Direct Connect and Transit Gateway by going to product pages. We have more details there on the limits, and also we have frequently asked questions in there about compliance or about how they generally work together. Also, you can look at the documentation for both the APIs and step-by-step guide on the console. And then we have previous sessions, like I have a webinar, which is Introduction to AWS Transit Gateway, and we have a couple of reInvent sessions that goes in details about the use cases and concepts in Transit Gateway, like routing domains, attachments, and propagation. Okay, so now as we've gone through the Transit Gateway and Direct Connect, we want to show you a quick demo on how would you use Transit Gateway with Direct Connect. For that demo, we assume that you have a Direct Connect connection. If you don't have one, you need to request one either through our partners or through our console where you get a Direct Connect connection. So in here, as you can see, I have multiple windows open, one for VPC console, and the other one is EC2 console, where I'm going to show you like an instance I'm running, and then here, Direct Connect console. So in this example, I have two VPCs. I already created them, called them Spoke 1 and Spoke 2. Each VPC have a subnet in it. So we have subnet 1 in each spoke and subnet 2 in spoke 2. And then there's a route table for each subnet right here. And I'll show you in details like this how the route table looks like. So right now, what I have in the route table is a local route and a 0/0 IGW. That's for accessing through SSH to the instance. Similarly, I have another VPC here with a route table. And then I have security groups that simply allow you to just log into these instances and just do a ping and SSH into the instance. So it just inbound rules is like one for ping, one for SSH. And then what I will do is in this demo is I want to be able to ping between my instances here, which is running in AWS, and my server, which is running on-prem over Direct Connect. So first step is you want to create your transit gateway. So let's say you go to VPC console right here, and then all the way to the left, you find transit gateway. Just click on that. Now I don't have any transit gateways created, so I create my first transit gateway here. I'll give it a name, like let's say demo TGW, just for that. And then you can give it a description here, demo. And then ASN, as we mentioned earlier, the ASN must be different from your ASN of your DX gateway. So here I'm using 12. In my DX gateway, I will use 13, like 6513. And this is other options, the different options like DNS support, which you want to do DNS resolution over transit gateway, or ACMP support which I talked about earlier, that allow you to spray traffic across VPN. And then you have the full route table, which gets created by default, and then v6 support. So let's create the transit gateway. Now this transit gateway takes a couple of minutes to create, so you can wait for that. So now we have created our transit gateway. It's available now, as you can see. So this is all the settings that we have provided for this transit gateway. Now the next step is to attach this to your VPCs. So here you go under VPC and the transit gateway attachments, and then you create an attachment. So we will here select the transit gateway we created, which is TGW, select the VPC, and then here we just give it a spoke one. And then we select which VPC. So here we select spoke one VPC. And then here give us an option of subnets. So since I only have one subnet, I'm just going to select that. But if you have your VPC with different like subnets and different workloads, basically you need to select availability zones where you want to place your transit gateway. So here I'm only using one AZ, so I just select one AZ. If I have if I have like 10 subnets in one AZ, 10 subnets in another AZ, it will show me two options here. I select like AZ1 and AZ2. Basically, it's just we place one ENI per subnet, per AZ, not per subnet. Okay, so here, similarly, we create another attachment to our second spoke VPC. Again, this is TJW, and then we call it spoke2. And then here we select our second VPC. Here it's in a different availability zone, as you can see, say 1B, so I will just select that availability zone. Again, if you have workloads in 1A, you can select that, or 1C, and so on. You can select different availability zones. Do that. And then it takes a couple of minutes to show that. While this is pending, I will show you how sharing works. So if you go to your console and you look for Resource Access Manager right here. Let's say you want to share this transit gateway with other accounts so that they can attach their VPCs. You can do that by creating a Resource Access Manager or Resource Share. And you go in here. And as you can see, you can share subnets or you can share transit gateways. So let's say I want to share transit gateways. I'll just select transit gateways, show me the option here. I say this is a transit gateway I want to share. I give it a name. Let's call it like a source demo, for example. And then here you select which accounts you want to. So you can select either sharing it within your org or cross org. You can allow like cross org, or you can allow sharing in there. So you can decide how you want to share in that, and then you can give it a tag, just normal tagging. What that will do, that will create a resource share, and that share will send an invite to the other account. The other account will accept, and then they will start seeing the transit gateway. And what they can do is they can just do the same thing, associate the VPCs with that transit gateway. I will not go through the steps, but I just wanted to show you how to share transit gateway with other accounts. Now I have my two attachments available. You can see like 1 and 2, and you can look at the details of the attachments, shows the VPCs and all. Next step is to go to the VPC route table and just make sure you're pointing towards this transit gateway. So in here, because I want to reach on-premises router or my on-premises network, I will just create a route toward the 192. So my on-premise network is a 192 network, so I'll just say 192.0.0/8, and then I will just here select transit gateway, and then it shows up. I just say create. So here my purpose is to reach my on-prem network, so I'm just doing the on-prem route. If I want to reach other VPCs, I can just put the 172 to point to transit gateway. So I can do the same if I want to get to transit gateway. So now I modified my VPC. That's an important step because if you forget to create a route, then the traffic from the instance will not know what to go next. Now I have a routes pointing to my transit gateway. I have my transit gateway. And one thing is you want to look at also is you can look at the transit gateway route table. So in here, the route table, I already have 2 attachments and they got dynamically propagated. So this is my first spoke. This is my second spoke. So now I have a transit gateway with 2 VPCs attached, routing setup. Now my next step is to go to my Direct Connect to set up my Direct Connect and get it hooked up with my transit gateway. So in here you go to the Direct Connect console. I already have a connection, which I provisioned. So first step is you create a Direct Connect gateway. So I already have one created, but I will just show you how to create another one just to go through the steps. It's pretty simple. Here, all what you need is call it like demo gateway. And then you just give it an ASN, which is different than the one you mentioned before. So I'm using 13 here. And that's the ASN that's going to be interacting with the transit gateway. So you just make sure you use a different ASN between your transit gateway and Direct Connect gateway. So I already have one. I will use the existing one, but I just wanted to show you how to create another one. It's pretty instantaneous when you create a Direct Connect gateway, it just shows up. Now, your next step is to create transit VIF, which is basically the VIF. Again, here I already have one which is already created. I did that just to save time on the demo, but generally you can just go through the steps of creating a VIF. In here, you just go and create virtual interface. You select transit as a type of the virtual interface. You select, you give it a name, like we can call it demo VIF. You select a connection. So you already have an existing connection. You just select the demo connection. And then a virtual interface, you can either create it in your own account or you can create it in another account. So you can decide if you want to create a virtual interface and just place it in another account. So really you can decide how you want to set up your networks or your accounts between Transit Gateway and Direct Connect Gateway, or if you want to have one in each account or separate accounts, and your VIF could be the third account. So again, all of them work cross account, so you can decide how you want to do that. It asked me for Direct Connect Gateway, so I will use the demo gateway. And then this is your VLAN, it has to be different for each that you create. And then the last step here is your ASN. This is your facing the customer gateway facing ASN. Here I'll just say 6410, for example. And then I create this. So that will create a virtual interface. As I mentioned earlier, I already have a virtual interface created and everything, so I will not wait for that to create. Now let me go back to the Direct Connect Gateway. In here, I have this Direct Connect Gateway, which already have a VIF attached to it. It already has ASN everything set up. Now, my next step is I created the VIF, I created my Direct Connect Gateway. Next step is to connect your Direct Connect Gateway with your Transit Gateway. And it's pretty straightforward. All what you need to do is go in here under Associated Gateways and then select Create Association or Associate. And then you select your Transit Gateway, the one you created. Now, in here, between Transit Gateway and your on-prem, we don't propagate the routes of Transit Gateway into on-prem. You have to specify which routes. The reason is the scale of the Transit Gateway can do up to 10,000 routes, so you cannot send all that in BGP down. So we ask you to summarize your routes when sending traffic down. So my Transit Gateways actually is can be summarized in a 172 range. So I can say like 172.0.0.0/8. That's basically all the prefixes of my VPCs fall in that range. You can again announce like 10 slash, or you can announce different prefixes down. You can decide how do you want to basically propagate your prefixes. And then now you create the association. So now your transit gateway will be getting associated to your Direct Connect gateway. This takes roughly 2 to 5 minutes to complete. So now we have took about like 5 minutes. So now we have it connected already. So you can see that your Direct Connect gateway shows up as an attachment here. So if you look at your Transit Gateway attachments, you can see the Direct Connect gateway and your both VPC attachments. It roughly, so if you just give it a name here, we can name it like Direct Connect. And then, oh, didn't take it this time. So now you have your two VPCs, you have your Direct Connect. One thing is you can look at also is try to look at the route table to see if the propagation has happened. Basically, your on-premises routes will be propagated here, and you can see it tells you this is one is propagated from your Direct Connect. So now you have a full end-to-end connectivity between your Direct Connect and your Transit Gateway VPCs. So I already, as mentioned, have an instance. Let's try to see if we can ping from that instance. So let's connect to that and do a quick ping test. And voila, we are able to ping our on-prem. This is an instance, 192. We're pinging it from 172, which is in AWS. So as you can see, we're able to connect our Transit Gateway with VPCs, two VPCs to your Direct Connect. And you can do that as I mentioned earlier, you can do that with 100 VPCs, 1,000 VPCs. You can do as many as you want up there. Key things to consider is like the limits we've mentioned earlier in the presentation, also the summarization. One more thing is to mention is that you can actually connect the Transit Gateway cross account to your Direct Connect gateway. It doesn't use Resource Access Manager, it uses a different mechanism. So if you go here in your, it's a bit hidden, so I just wanted to highlight that. If you go on the Transit Gateway screen over here in your Direct Connect, you can create association. And then in here, when you go to that screen, it will ask you to create a Transit Gateway. If you don't have one, you can create it. If you already have one, what you can do is you just select that Transit Gateway. So let's go back to the Direct Connect screen right here. And then you can select that Transit Gateway. And then you can say view details. So you can see the details of that Transit Gateway. And then from here, you can associate to Direct Connect Gateway. So here you see a different option now. You will see the option of like my account or another account. So you can now, if you as a Transit Gateway owner, you can associate to Direct Connect Gateway in your account, which I already did. This is the one I showed you. It was Direct Connect Gateway and Transit Gateway was in the same account. But you also, if you are the Transit Gateway owner, you can connect to a Direct Connect Gateway in a different account. So basically you can do it across account. So you can think of it this way. You can Direct Connect to your Transit Gateway across account, and also your Transit Gateway can connect to VPCs in different accounts. So everything can go across account boundaries right now. With that, I concluded my demo, and I open the floor for questions. And if you have any feedback to us, just reach us through tgwfeedback@amazon.com. Thank you, everyone.